This conference will now be recorded.
Hello everyone, good morning, good afternoon, or good evening. So let's see, in today's session we have done with user administration and all the modules. Now let's start talking about network configurations and troubleshooting. See, when we talk about networking, networking is a connection between two or more devices, right? Whenever you have two computers and you want to exchange the information, then you will use networking concept. But networking is not that simple that you keep two machines in front of each other and they can communicate, right? We need certain components to be working perfectly on its place in order to establish networking. So the major components that helps in proper communicating is NIC, that is Network Interface Controller or Network Interface Card, media, topology, protocol, and IP address. When you have all these things, then you are going to get networking to work properly. Now, when we talk about NIC or Network Interface Controller, it is the Ethernet adapter through which the communication you are going to establish, right? So every computer needs to have a network adapter, either wired adapter or wireless adapter or whatever it might be. But we need a network adapter in order to have a communication established. Now, these network adapters will have different speed to perform, different MAC addresses that would be assigned to it for better communication. I'll talk about that in a while. So let me take a notepad because I have to write something. Okay, let us say that you have two machines. Now, if they want to communicate with each other, they need either a wired Ethernet adapter or network interface controller or wireless, anything through which they can communicate. Now, these adapters will also have some naming conventions. Now, what's the name that is given in Linux environment? Windows has different names to call, and different operating systems will call the adapters with different names. In Linux, especially in RHEL 6, the naming convention used to be ETH. Basic rule of adapter in Linux is ETH only, but on the foreground by operating system, these names might get changed. So earlier it used to call as ETH0, one more adapter ETH1, one more adapter ETH2. Like that, it used to go with adapter names. Then in RHEL 7 as well as 8, now you will find the names to be very different. These names in RHEL 7 and 8 are not fixed, and it changes from uh, virtualization to virtualization or physical environment to physical environment. What adapters you are using. Realtek adapter might have a different name. Intel adapter might have a different name. Like that, it changes the name time to time, right? And virtualization like para virtualization, different name, Oracle virtualization, different name, or workstation may have different name, KVM, OVM, or VMware, Citrix might have different naming convention. But anyway, initial name would be EN. When you say en, it has other things after en, but initial two things would be en. Sometimes it may use the names like ens0, ens1, ens2. Sometimes it might use ENP0S3, ENP0S8, right? And sometime it might use something like EN00123, something like that it might use, depending on which environment you are working. All right. Now, we should not worry about what name it is taking. If you run a simple command ifconfig or ifconfig, you'll come to know whatever might be the name it is using. So that does not have to bother us. Okay, but there might be another problem over here. What's the problem is maybe you are having an adapter ENS3 here, and the other machine is also having the same name adapter. So my first machine has an adapter name ENS3, and second machine also have the adapter name ENS3. Now when my first machine ENS3 try to communicate with second machine's ENS3, due to same name, there is a chance of conflict in communication. To avoid this conflict, what networking world has done, for each adapter they uses a unique MAC address, media access control address, right? Now that media access control address or MAC address is unique for every adapter. Each adapter you will find a unique MAC ID, and no two adapter in the world or in the space also where machines are used, no two adapters will carry the same MAC address. Every adapter will have a different MAC address. And whenever you are communicating, these simple names will be converted into MAC address, and MAC to MAC communications will be happening. So this is how it is going to work. But guys, one more thing is here, that when you have two machines with one adapter, will they communicate just like that? No. See, I need some medium through which my first machine is communicated with second machine or connected with second machine. Now, what do you think is the best example of medium? See, if it is a wired environment, we use network cables. If it is a wireless environment, we use Wi-Fi modems or routers that would be available through which two machines can communicate or connected to each other. So first requirement is to have adapters. Second requirement is to have some medium through which both machines can be connected or communicated to each other. So two requirements we have done. Now let's move on to the third requirement. See guys, what type of cable we use, that is not our burden, that is not our work also. It is the work of your network team who are experts in networking. They will decide that what type of adapter, what cables to be used and all that thing. Different cables are there, RJ45 adapters would be there, Cat5, Cat6, different cables are there, twisted pair and all. So it all depends on your network team how they are deciding and what they are doing. We don't have to interfere in their work. One more thing is their topology. This is also the responsibility of network team, but just for understanding we are discussing it. Topology is the scheme or design, or in fact an architecture in which all the machines are connected to each other. See, if you have 3 4 machines in your environment, there is no problem, you can connect the way you like. But when you have a huge environment, hundreds of machines are there. Now, don't you think we should require a proper designing or architecture? If designing or architecture is not proper, then always there will be lag in communications. We will have slowness, packets will go missing, lots of problems will be there. So we have a topology that is again decided by your network team. We don't have to worry about this thing. Different type of topologies are there: bus topology, ring topology, star topology, mesh topology, tree topology. Whichever suits your environment, they'll decide it. Our work as a system admin starts from here: protocol. See, protocols are basically rules of networking. network protocols. Whenever you try to communicate from one machine to other machine, the information will be sent and received in the form of packets, network packets. So what would be the proper packets to transfer? What would be the size of the packets? What happens if the other side is not accepting it, right? All that things depends on what protocol you use. Now if you see the protocols list in ISO model, there are many protocols to discuss, but as a system admin, we should be aware of at least two protocols which are very important: TCP, IP, or UDP. Most of them comes under TCP or UDP category only. TCP stands for Transmission Control Protocol, whereas UDP stands for User Datagram Protocol. TCP, it is connection oriented. UDP, it is connection less. So what does this means? It never means wired or wireless. Both will be connecting on wired environment as well as wireless environment, right? Connection orientedness means, see, TCP is one of the secure protocol to work with. It has authentications, username, passwords, and other restrictions that has to be cleared. So someone needs to be there, or you have to arrange something that it clears the authentication. Without clearing the authentication, you cannot communicate using TCP. It's a secure thing. Username, password, other things would be there. Whereas not that much reliable. Obviously, security is missing, so reliability will always be in doubt. Then one more thing is there, TCP acknowledgements will be sent and received. See guys, whenever you do any activity with TCP, it so it shows how much you have uploaded, what is the result, upload was successful, failed, download was successful or failed. Everything it is going to give you a description, an acknowledgement. Whereas UDP is not going to provide you any acknowledgement. You have to check manually whether your work is completed or not. Now this is the reason TCP is slow in communication. Obviously guys, it has to go through authentications, it has to provide acknowledgements, so overall process will be little slow. Whereas when it comes to UDP, it is faster in nature because there is no authentication, there is no acknowledgement. Overall concept will be faster. Now, when it comes to protocol number for TCP is 6 and protocol number for UDP is 17. This is not port numbers, these are protocol numbers. See, in the list of rules, in the list of protocols, every rule has a number. So same thing for TCP, you have rule number 6, and for UDP, you have rule number 17. Now, which application uses TCP and which application uses UDP? See, simple thing is there, the application that wants security, they'll definitely go with TCP, and the application who are not bothered about security but they need speed, they would go with UDP. Like HTTP, FTP, SMTP uses TCP, and DNS, DHCP. These are one of the few example I am giving you. DNS and DHCP kind of application, they uses UDP. See, HTTP is a website where you are trying to open or you are trying to log in and do activity, so it needs TCP. Same way FTP for file transfer protocol. But let me tell you one thing, FTP is one of that service or application that use both protocol, TCP and UDP. So for connectivity, it use TCP protocol, and for exchanging data, it use UDP, right? SMTP, mailing system, it definitely use what? TCP, because mails you are sending, receiving, security is important. Same way here, DNS and DHCP, they stores only IP address. So it doesn't matter if someone comes to access the IP address. They are not worried about security. They need speed in communication. So they would be depending on UDP. Now, fifth and a very important component over here is IP address. See, IP address is a unique identity that is given to your machine for communication, using which it can communicate to others and others can also communicate to it. So to communicate and to get communicated, every computer requires to have a IP address. So IP address can be considered as your mobile phone number or email address through which you can communicate to others and others can also communicate. And it is unique for you or your mobile phone or same way your computer. Now, IP addressing has further branches inside it. Let's try to discuss about that. There are two types of IP addresses, guys, IP version 4 and IP version 6. So still we are working much and much on IP version 4. 6 has also been introduced, but it is more to be used as a public IP on internet. Privately within our organization, if you are working, you still work on IP version 4. And in our curriculum, we are only going to discuss IP version 4, which is useful still. So IP version 4, IP addresses, let me put it down in a notepad for a better understanding. So if we go with IP version 4, there are basically two IP version 4 and IP version 6, but we are going to talk only about IP version 4. So IP version 4 IP is divided into four octet values, 0.0.0.0, and maximum you can go up till 255, 255, 255, and 255. See, normally everything is used by the system in binaries. Even this IP address is available in binary, but the conversion is in this format for our usage, for our user-friendly nature. So the valid IP, what actually can be used is between 1 to 254. You cannot assign 0 or 255 to any computer. You have to use 1 to 254. Between this range, whatever IP you want, you can assign it to your computer and you can work with. But 0 and 254 cannot be used. They are reserved for some special cases. Now, again, what happens is that 0 to 255 you say, or 1 to 254 you say, is divided into classes, categories. What are those categories? See, we have 5 categories. Class A. Valid IPs, I'll tell you. In fact, 0 also comes under class A, but I'm just writing down those IPs that can be used by you. So class A IP can be start from 1 and you can use up till 126. 1 to 126, these IPs comes under class A category. And class B is also there. Class B uses 128 till 191. Same way you have class C, which starts from 192 and it goes up till 223. All right. Then class D uses from 224 till 239. And class E uses from 240 till 254 or 255, whatever you might consider that. So these are the 5 categories or classes of IPs which are available in IP version 4 that you can assign. So 0 cannot be used, so I started literally with 1 and I ended up to 126. Now guys, one more thing is there, you have 3 types of network. According to that network, these classes are favorites. Like you have LAN, you have WAN, and you have MAN. LAN stands for local area network. That means the networking what you do within one premises, one building, one room, whatever networking you have done or communicating, that is called as local area network. Then you have WAN, wide area network, that you do between two premises, maybe two buildings side by side or little different distance, something like that. So that comes under WAN category. Then you have MAN, metropolitan area network. That means between two geographical location, two cities, two states, or maybe two countries, something like that. When you do a bigger way of communication between two geographical location, we call it as MAN, metropolitan area network. So what happens is class A and class B, these two IPs are hot favorite for class A and class B for WAN and MAN. Both will be using it. So let me put it down like this. WAN and MAN both will be using class A and B. There is no such rule that you should always use it. You can use any IP whichever you like, but I'm just telling preferences that for WAN and MAN kind of communication, we prefer going with class A and class B IP. That means you take any website, maybe it is Netflix or Amazon or Google or YouTube, you'll find that they are using IPs between class A and class B categories. Now, for your local communication, the category that is very much famous is Class C. Class C is reserved for the concept called local area network. So WAN and MAN categories will be using Class A, Class B network. Class C is used for local communication, whereas Class D is used or preferred for multicasting, and class E is reserved for research and development and also broadcasting. Right now, there is a difference, guys, between broadcasting and multicasting. I don't know if you are aware of it. Broadcasting is like radio frequencies. You are at some place and you are sending those frequencies. Whoever has radios turned on, they will receive that signals and they will receive the packets and they'll display the noise or anything, whatever. In computing also, from one to many, when you are communicating or you are sending some information forcefully kind of thing, so we use broadcasting. From one to all, whoever is available in the network, they will receive that communication. So whenever we want to do broadcasting kind of thing, so we will do it with the help of class E network will be used. Plus class D is using multicasting. So what is that multicasting? I don't have to go in great detail about it, but anyway, just for your information, like we have Netflix, you have an account on Netflix. Everyone has, maybe all five of us has Netflix account. Now we will log in and we will play one movie over there. So what we are doing is Netflix is available for everyone, but you have to make a request to receive something from there. So at a time, same movie can be played by millions of people, but they are requesting and getting that particular thing. So this is the difference between multicasting and broadcasting. Broadcasting is available by sender, free to air. So whenever sender sends it, all has to receive it. Whereas multicasting, what happens is it is available for everyone, but whoever requests, they only get it. Like this time, I'm delivering a lecture, but only four people are receiving that lecture because you have able to join through GoToMeeting. You make a request to attend the meeting. So from my side, I'm sending my voice and my videos, and you are able to receive it. This is multicasting. Same thing if I do it through radio frequencies. That is the best example. Whenever a radio jockey plays a song or discuss something on the radio, whoever turn on the radio, whether they have requested or not, they will be receiving those things. right? So mostly like that you can understand, but again, it's a very deep concept, guys. According to my knowledge, whatever best I have understood, I try to convey that. But actually, networking is itself like an ocean. It's a great concept. So when you go with some networking classes like CCNA, CCNP, CCIE, there you'll learn more wonderful things about networking. Anyway, so the useful classes, what is used everywhere is class A, class B, and class C. Usually, we don't touch DNE, but if you want, you can touch that also for your private network. On a public ground, you'll see A, B, and C is widely used, right? DNE are usually used for multicasting and broadcasting services. Okay, now one more thing is there. Every IP address require a concept called net mask, or we call subnet mask. So what is that net mask or subnet mask, and why do we require it? Let's try to understand. See guys, by seeing the IP address after learning the categories, we'll tell that which category this IP is coming, which network this IP is coming. But how does your computer realize that what is the network I'm working and what is the IP address I'm working with? Normally, when you type any IP like 192.168.10.20, guys, IP address is divided into two parts: host ID and network ID. So network ID is like your country code or like your area code in which you are living. When you see at your house address, normally it happens that our house address is divided into two things: area code and a specific identity given to my house, right? So same way, IP address is divided into network address, that is nothing but your region, your area, or your country maybe in which you are, or your state in which you are, or city in which you are. Then one or two or four or five last few digits will be host ID. Host ID is something which is dedicated to my computer. So by seeing host ID, that is the unique address what I'll be getting. Now, how do you think this number denotes what is the network address and what is the host address of my machine? For that, we use subnet mask. So every class will have a subnet mask. Like you see over here, class A IP address should have a subnet mask 255.0.0.0. Class B should have 255.255.0.0, and class C is having 255.255.255.0. These are the subnet masks that are dedicated to each class. 4 and 5 will not have any kind of subnet mask. That's a different category. Let's not go into that. Right? So these are the default subnet masks that has to be used with A, B, and C. But frankly speaking, guys, in your organizations, your network team can use any kind of subnet mask they like. So these are not mandatory subnet mask. If you see the heading, it is default subnet mask. So if your networking team has done any subnet masking of their choice, they'll let you know what subnet mask to use. If no subnetting has been done, then you can use these default values, which are widely used most cases. But how these subnet masks will tell the computer that what is the host ID and what is the network ID? Let's try to understand that. See guys, I told you that everything is in binary code. Even these values, what I'm going to put, 255, 255, 255.0. This is class C network. So I have given 3 times 255 followed by a 0. If you see each 255, if you convert into binary codes, See, we understand human readable numbers, human need readable, what I can say, languages. So we go with these numbers. But what your computer does is it converts that each thing into binary code. Binaries are nothing but zeros or ones. So basically 255, when you convert into binary, it becomes 1, 1, 1, 1, 1, 8 times 1. Now when you multiply it, 1 into 1 into 1, oh, I should have done a little different way, no problem. Then into 1, into 1, into 1, into 1, and lastly into 1. Guys, when you multiply 1 8 times, what would be the result you will get? Obviously 1 only. You won't be getting 8 because you're not adding, you are multiplying. 1 into 1 into 1 into like that, if you are doing for 8 times, it becomes 1. So can I consider or can I assume 255 as 1? Okay. Now when you assume each 255 as 1, 1, 1, 1, and this, let us keep it 0. See, whenever the communication happens, automatically the IP addresses will be multiplied with subnet mask. So 192 into 1, it becomes 192. 168 into 1, it becomes 168. 10 into 1 becomes 10. 20 into 0 becomes 0. So this becomes nothing but my network address. So I am communicating with a network 192.168.10. Something which is getting multiplied by 1 will be treated as network address, and something which is not getting multiplied by 1, instead 0, then this will be considered as a host address. So this consider network you considered as an area code, and that 20 host ID is the special unique identity given to your computer. So all that number that is given does not belongs to any computer alone. The network ID belongs to the network in which you are communicating, and host ID is a special ID that is given to your computer alone. Right? So if you go with class A, class B, you'll get many host ID and less network ID. So that is the reason on internet you need millions and millions of IP. So in that scenario, the internet uses class A, class B network. For a local environment, you use less number of host IDs, so we go with class C network. That's the reason class C is favorite for local network. Whereas A and B, it is good for public platform for having more IP addresses. Okay, now one more thing is there. From Red Hat 7, we are not using such a big number, 255, 255, 255 kind of thing. Now it's the era of shortcut, guys. Mostly these subnets are also mentioned in shortcut. Instead of writing such a big value, I want to finish it up in just 1 or 2 digits. So in that scenario, let us say the same thing, 55. Last time I have did multiplication. This time, for example, I will remove multiplication and I'm going to put plus 1 plus 1, oops, plus 1. So I'll be removing all multiplication, and in place of multiplication, I'm going to put plus. If 8 times you add 1, 8 times, what would be the result you will be getting? 8. So in this scenario, consider 255 as 8. In the previous scenario, when subnet mask was multiplying, we multiplied it. This time, assume that you are adding 255 8 times. When you add, the value you'll be getting is 8. So assume wherever 255 is there, we are going to call it 8. So instead of writing 255, 255, all that thing. See, 255 triple zero. Only one 255 is there. So I can, in place of 255, I can just write /8. Now, when you have two 255s, 8 plus 8. So instead of writing 255, 25500, I'll be simply writing 16. Then you have 255, 255, 0. So 3 to 55, 8 plus 8 plus 8, what it becomes? It becomes 24. So now there is a new era where instead of writing such a big thing, you can simply declare your subnet mask with your network as /8/16/24. That's the way you can write it out instead of writing such a big values, whatever we have discussed or seen. Okay, right. So now let us move ahead. I hope you have understood what it is. For your explanation, I have kept all that theory things what I have discussed in manual. You can read through and understand that how it is working. Okay, all right. Now, last thing what we have to talk about is gateway. Let me just get rid of these things. Assume, guys, you have two machines, machine A and machine B. Two machines are there and they are using two different networks, not classes. In the class also you have two different networks. For example, it is having an IP 192.168.10.20 and the other machine is having IP 192.168.100.32, for example. So you see this machine is working in a network 192.168.10 and the other machine is having 192.168.100. Both are into different network. See, in networking there is a rule that two machines in a different network cannot communicate directly. So 192.168.10 cannot communicate with 192.168.100. Both are two different network. If they wants to communicate, both should be either in 192.168.10 series or 192.168.100 series. Otherwise, they cannot communicate. So does it feasible, guys, or is it possible that every time you're communicating with different network, you'll be sitting changing the IP addresses of your machine to get compatible with that network? Suppose class A is my production machine and class B is also my production machine. So if I change the IP, production will be affected. And in fact, every now and then when I'm communicating with different networks, it is not feasible for me to change the IP address. Then what's the solution over here? See, the solution over here is to use a bridge that allows you to communicate without changing the IP address. So what we do, we'll put a router or a gateway. Physically, we call it as router, but concept wise, we call it as gateway. So what this router will do, it will allow you to communicate to any different networks without shifting or changing your IP. So isn't it beautiful? Instead of shifting the IPs or changing the IPs, I can keep my IPs and I can communicate with any network. The best example is the modem that is provided to you by your internet providers. Whenever you purchase an internet connection, most probably they'll put an internet router at your home, right? So that internet router is allowing your laptop, which is totally in a different network. So from that local network, you are communicating to public network. You are communicating to Amazon, Google, Netflix, Citibank, or whatever websites you want to reach. Probably they might be working in different network. So whole our working network is connected with series of routers. That's how you can communicate with any machine to any machine. In fact, nowadays there is a concept of network switches like layer 3, layer 4 switches that has built-in routing concept inside it. Many great concepts are there. Anyway, so these routers or gateways will also have some IP address. and you need to tell your machine that through that gateway you have to communicate. Especially whenever our machine wants to communicate with internet, it definitely needs to have a gateway IP or a router IP. So for this series, generally the IP that would be used is 192.168.10.1. Now again, it can be any IP your network team will provide you, but usually the first IP in the network is used for the concept of gateway or router. But it's not fixed. It can use anything, but usually the first IP in the network is used for gateway IP or network IP. Sorry, router IP. Same way, same router from the other side will be communicating through 192.168.10.100.1. So this is the way, with the help of these gateways, two different networks can communicate, or you can communicate with internet and all, right? So anyway, these are the basics of networking. I just want to brush it up before touching the Linux part of networking. So every system admin must have knowledge about network, at least this much. Whatever I tried to show you is a very basic concept, guys. Anyway, when you go for networking proper courses or something, there you'll learn a huge thing related to networking. Now let's talk about how to change the networking and other concept in Linux environment, especially under Red Hat network. So first of all, after login, if you want to check what is the IP address of your machine, the most common command you use is ifconfig, interface config. So it shows you how many adapters are connected to your machine. This is the name ENP0S3. And what is the IP address? What is the subnet mask or net mask? And what is the broadcast address through which it can communicate to this entire network? And what is the MAC ID? Right, this is IP version 4 IP. If you want to check IP version 6 IP, this is your IP version 6 IP. So as we have not talked about IP version 6, let's ignore it. Then one more concept is there, guys, LO. See, loopback. I told you that the IP addresses starts from 0 to 254. So class A network, I started with 1 and I went till 126. I did not talk about 127. 127 IP is reserved for the concept of loop back. Every computer by default will have an IP after installation, 127.0.0.1. This is called as loop back address. There are many benefits of loop back. I'm going to explain only one of the smallest concept for which loop back is used. See, suppose you have a doubt that your adapter might not be communicating perfectly. So how you can test whether your adapter is sending and receiving the packets properly? Being on the same machine, you will ping the same machine. So you are on 192.168.10.20, same machine you will ping. So with this, what it does is it takes the packets outside, same packets it bring it back. So with this, you can diagnose whether your adapter is sending and receiving packets properly or not. So for that purpose, usually we prefer using 127 network, right? For the concept of loopback, there are many benefits of loopback. One of the benefit I told you. So by default, after installation, you will find automatically your system will be having an IP 127.0.0.1. This is called as loopback IP. It is also showing virtual bridge 0. Ignore it, as we are using a virtual machine. All virtual machines will communicate through your virtualization console network with the help of that bridge. So ignore it. We don't have to worry about that. Now, out of all, I'm only interested to see ENP0S3 detail. Then you can say ifconfig only show me ENP0S3 detail. So it tells you that ENP0S3, this adapter details is this. Or in summarized way, If you want to see, you can say IP space A. When you run IP space A, it tells you what is the loopback IP, first IP, then your adapter IP. You see IP address followed by 8, 24. So this is nothing but your network subnet mask. 24, 8, 16, 24, 32, like that it is going to present it. Okay, all right. Now every computer will also get some name. The name of your computer can be find out by using a command host name. Let us say I don't like that name and I want to change that name. To change the name, you have to again run hostname command followed by whatever new name you wanted to call it with. For example, I want to call it something called my RHEL 40. Now, if I run hostname command, you see that the name is changed. That's fantastic. Let us say that I want to check whether this name is permanent or not. See, I don't want this name to be again bring back to mlinux 40. I want to keep it myrel 40 always. The change what we have done is temporary. And you know why? There is a configuration file that holds your host name. The name of that file is etc hostname. When you just go and read this file, you will find that it stores still the old name. You observe earlier the name was mlinux 40, I changed it to myrel 40, but the host name configuration is still holding the old name. This is the reason this name what I change will remain only till system is up. As soon as you reboot the machine, after rebooting, it reads the configuration file and use the old name, which I don't want. I want it to give me new name every time. So I need to edit this file and put the new name. So let me go to vim etc host name, delete the old name and type the new name. Save and quit. Now it is guaranteed that even a system gets rebooted, we are going to get the new name what we have kept, that is myrel 40. But you see your terminal is still showing the old name. What to do about this? Nothing to be done. Just log out and again log in to same machine. Whenever you have changed the host name permanently, just log out and log in. And you will find after login, it is going to print the new name always. So no need to reboot for your prompt. Just log out and log in and it is going to get updated. So this is the way how we can change the host name permanently. Same way guys, there are other important configuration files what we have to discuss. The first configuration file is etc um, resolve.conf. Okay, before that guys, I'm so sorry. Before touching that part, I told you how to change the host name, but this method of changing the host name is obsolete, outdated. No more we are using this method to change our host name permanently. You know why? Because there is a new command that has been introduced in Red Hat 7, which is carried forward in 8, which is host name CTL. This is wonderful command guys. When you run just hostname CTL, it prints very important information about your computer. What is the permanent host name? You are working on a physical machine or virtual machine. If it is virtualization, which virtualization you are using, and what is the operating system version you are working with, what is the kernel version you are using, and which architecture you are working, 32-bit or 64-bit. So you see it says we are working with 64-bit. So using this same command, you can change the host name permanently. How to do that? I'll say host name CTL. there is an option called set hyphen host name. Now let me type the new name. I'll again bring it back to mlinux 40. Let me add something vpts.com. See, this extra thing, whatever I'm adding, is called as domain name. It's like organizational name. Every computer should have a suffix with your domain name. Now, that's not a website name. Every organization maintains some domain name like hetero.ly or something.local. So, some host names followed by domain name. This is called as FQDN, fully qualified domain name. So, I also prefer same thing. Now, if you run hostname command, it tells that your present hostname is mlinux40vpt.com. Just go to etc hostname. Did you see that it automatically updated the file? So I don't have to change the hostname and then update the file. You can now simply do hostname ctl command, set hostname, and change the hostname permanently to whatever you want, right? So this method is now widely used from Red Hat 7. The other method, what I have told you, is still Red Hat 6 and lower version, where hostname ctl command was not there. Now, let me talk about the other configuration, etc resolve.conf. Not only Linux, guys, but every Unix has this configuration file. What's the role of this config file? It stores the information about the gateway. I told you that, sorry, DNS, not gateway, DNS. Now, what's that DNS? DNS actually stands for Domain Name System, which converts user-friendly names into IPs and IPs into names. See, guys, suppose all the computers in the world, they are working on IP address. Even the websites like Amazon, Google, YouTube, Netflix, they are all working on IP addresses. Now, if I ask you to remember all the machines with their IP addresses, will it be an easier task? How many IPs can you remember? Very less, hardly 8 to 10 IPs if you remember, that would be big stuff, right? So what they have done is, although every machine is working on IP addresses, but to make it easy task for the end user, they have added a converter or translator or resolver. What it does is, when you take a browser or your computer and type a name, automatically the DNS will convert that name into IP. It's like your telephone directory. So when you search for the name, it present numbers, and when you search for the number, it present names. So whenever you take a browser or your computer and you type a name, it converts it to IP and make you reach that computer. Or if you type IP will be translated into host name. Let me show you an example. Like I'll say ping www.google.com. You see, I have typed the name here, google.com. What it does, it converted that user-friendly name into IP address. This is what happens when you take a browser and type a name, the name will be automatically converted into IP address, and then you will be allowed to reach to that website or that computer. So this DNS is also a separate machine which is configured for this activity. Now, when it is a separate machine, it will also have an IP address. So you have to inform your machine that who is DNS, whom to ask to resolve the names. So if you have a DNS in your environment, go to resolve.conf and use a keyword name server and type the IP address of that machine which is working as your DNS server. Now, I don't really have a DNS server. I'm just putting that IP, that format, to show you that if you have a DNS, how to put. But we'll definitely see the effect once we learn DNS server. So in the coming classes, we will learn DNS server. Then we will find out how to work with DNS, and then we will put this thing. But if you have a DNS in your environment, this is the way how you have to put the name server keyword followed by DNS IP. Now, guys, if you have DNS, then you can connect to any machine with names instead of IP. Like if you want to test the communication to any machine, you'll use ping command. So if I say 192.168.10.50, see, I have powered on both the machines for today's class. You remember we installed two machines, one with normal installation, other with LVM. So I powered on that machine also. That's the reason I'm pinging that IP. So when I ping followed by IP, it connects to that machine and it is going to reply back whether that machine is communicating or not. But same machine, if I want to ping with name, maybe I'll say ping ML50. Is it working? Or ping mlinux50. It says no, there is no DNS server available which can convert that thing. So if you have DNS, that names would be converted into IP and you can reach any computer easily with with names instead of IPs. Now, what I want to do, I don't have DNS, but still I want these two names to communicate with 192.168.10.50. How is it possible? See, the possibility comes here. There is a file called etc hosts. What is the role of this file? etc host name that stores the host names. Resolve.conf stores DNS server IP address. etc host is like your telephone directory or your personal contact directory. I'm sorry. In your mobile phone, you have a contact lists. So whoever your friends and known fellows are there, you will store their numbers with some name for your benefit. So that whenever you want to call, you'll just search by the name and you'll contact them, right? Same thing you can do. This is not DNS activity. This is your personal contact lists. So go to this file. Let me edit this file. Now in this file, I'm going to put IP address. So I'm storing a telephone number in my mobile phone like that. 10.50 with what name? Maybe I want to store it with the name mlinux50. Let me save and quit. Now if I say ping mlinux50, last time when I told it, it says no service. But now did you see it has resolved it? So it's like in your phone you have added a contact and every time you want to contact that fellow, you'll just go by name. So here also I stored the name and when I say ping that fellow, it started to communicate. To break the pinging, you have to press Ctrl C, automatically pinging will stop, right? Or if you want to ping only certain amount of time, then say ping count mlinux50 or IP address. So I told stop after 3 counts. C stands for count and 3 is number of times you want to repeat. So automatically after 3 times you see the pinging stop. This is the way how you can store a name in your contact and communicate if DNS is not there. If DNS is there, putting a name in etc host is not worth. One more thing I'd like to show you, you can put multiple names for same thing. Like you can come here and you can say one more name ML50 with a space. So first name is this, second name is this. You see, both will work. Sorry. Now if I say ping mlinux50, last time I did that, that is also working. Now if I say ping ml50, both are working. So you can store multiple names with one IP. Ideal is only to keep one, but if you want, you can keep more than one name with an IP address. So that's how it can communicate. In fact, you see with the ping, if you press double tap, it is presenting the names that can be communicated. It is displaying your contact list. Which one you want? I'll say mlinux50 like that, right? So let me just go back in etc hosts and remove this thing. I don't want any IP as of now. Maybe in future if required, we will see. This is the way, guys, how you can make the changes in this configuration file and make it work perfectly according to our requirement. You can also check some details about your adapter by using a command eth tool and the adapter name enp0s3. So it tells you little more detail like what port you are using. TP stands for twisted port, and which duplex you are using, full or half. Full duplex means two-way communication. So this adapter is sending and receiving both the things. If it's showing half, that means it is only sending, not receiving. Most importantly, what is the speed of the adapter with which it is communicating? Also, the link is working fine or not. Link detected? Yes. Okay. Same thing you can get in a shot by using MII-tool and the adapter name ENP0S3. So it tells you that this is the details like ENP0S3 is having space 1000 Mbps, FD stands for full duplex, link is working fine, cable is connected and adapter is working fine. Anyway, these are a few things, guys, what I showed you in today's class. Tomorrow's class is very, very important, where we are going to learn how to assign the IPs, how to make changes in the IP addresses. There is another concept called connections, which I don't want to touch today. Tomorrow we'll touch that thing, and also we will learn another great and very, very critical concept in networking, bonding or teaming. Earlier we used to call it as bonding, but now we are calling it teamings. So we'll learn these two very critical things tomorrow. Today I just want you to have some R&D. If you don't know much about networking, this is the time. Just go through a manual, go to Google, YouTube, and gather some information about this IP version, 4 IPs, and other things what we have discussed for your better knowledge. So we'll stop the session here, guys. If you have any queries or questions, you can put your questions now. All right. So if there are no questions, then we'll wind up the session here. Let's meet up tomorrow. Don't miss tomorrow's class, guys. It's very important. So see you tomorrow for our next class.